Hey, good people. We are in chapter 5 and we're looking at inequalities, and we're in section 5.3, which I think you guys actually already have the skills to do pretty well with, but I think we're going to use this time to kind of review some concepts and things that we need to make sure that we have it perfect. So section 5.3 is really solving multi-step inequalities, which you're going to see is a lot like solving multi-step equations. Let's take a look at the first example. By the way, there are no vocabulary words. Yay! Okay, so example 1, we're going to solve a multi-step inequality. Here it is. Mrs. Jones earns a monthly salary of $2,000 and a 10% commission on her sales. Her goal is to make at least $4,000 per month. Write an inequality to determine the amount of sales she needs to meet her goal. So really, let's just dive right in there. We know she gets $2,000 per month, which is her salary, which is based on what her agreed contract is. She's going to get that no matter what. But the variable part of her payment or her work, the amount of money she's going to get for work, will be the 10% for her commission sales, and the 10% commission for her sales. And we don't really know what the sales are, so we're going to put an X there. So we know that 0.10 times X is going to be added on to her $2,000. And we know that she is desiring for this amount to be at least $4,000 per month. Think about what that means. She wants the amount that she actually brings home to at least be $4,000 per month. That means she wants it to be greater than or equal to $4,000. All right, think about that. If you at least want something, you'll accept more than. In fact, it's probably desirable to get more than that in her case. However, the least sometimes makes students think that they need to write it this way because less than least, but that's not the case. So I just want you to keep that in mind. That's why I overstress that a bit. All right, so now the thing that we have to do here is simply solve it, and we can do that. We're going to isolate the X term. We're going to subtract 2,000 on both sides of the inequality. When we do that, we're left with 0.10x is greater than or equal to 2,000. We know that to isolate x, we're going to have to divide by 0.10 or 0.1, however you see it. And then when we do that, we're left with x is greater than or equal to, well, when I divide a little tiny number into a big number, that number gets bigger, the result gets larger. And in this case, we have 20,000. So whatever she's selling, she's got to sell $20,000 worth in order to get the 2,000 to put her over 2,000 or more, of course, to put her over her goal for the month. Let's take a look at another example. Example 2, inequalities involving negative coefficients. So here we have an inequality, pretty straightforward. We need to solve for y. I'm going to rewrite it here. So I have minus 11y minus 13 is greater than 42. I like to draw a little line down here to kind of keep track of what I'm doing. I'm going to leave my y terms over here. I could drag it over here and then put my constants over here, but that's a lot of dragging things around. And I think I'm a sophisticated enough mathematician where I can have my y terms on this side and my constants over here. So if that's the case, this 13 has to go, and I'm going to get rid of it by adding it to both sides. Boom. So I get negative 11y is still greater than 42 plus 13, which is 55. The next thing I'm going to do is divide both sides by negative 11. I hope you heard that. I want you to have that weird sound in your mind every time you divide or multiply both sides of an inequality by a negative, because I want to alert you to the fact that when you do that, the sign changes. Please don't be mad at me for that. All right, so the sign flips because I'm dividing both sides by a negative 11. So I'm left with y is less than negative 5, and that's my final answer. Let's take a look at another example. Example 3, write and solve an inequality. 5 minus 6 times a number is more than 4 times the number plus 45. So remember, this is an inequality. So is doesn't mean equal. We're in the same way. We need to use this whole phrase is more than to get the inequality sign that that the author of this sentence is trying to express to us. So 5 minus 6 times a number, right? It doesn't say 5 less than 6 times a number. It says 5 minus. So that's giving us kind of instruction. Take 5, subtract 6 times a number, and that is more than. So is more than is going to give us that sign, is greater than 4 times the number plus 45. I'm wondering what kind of number this is. 5 minus something, something. I'm thinking this number must be negative. Let's see what we get. So we're going to actually solve it. We've set up the inequality as best we can, and we're going to solve. We're going to get our n terms on one side. I vote for this side, and we're going to get our constant terms over here on the other. And so get rid of what is not a constant term, and that would be this 6n, this minus 6n. I'm going to get rid of it by adding 6n's to both sides. So then I'm left with 5 is greater than 10n plus 45. Almost done. I've got to now, since I only want n terms on this side, I know that looks like an h. Let's make it more n-like. I don't know if that helped. Since I only want n terms on this side, I'm going to subtract 45 from both sides of my inequality. I'm left with a negative 40 is greater than, because negative 40 plus 5 gives me, negative 45 plus 5 gives me a negative 40, is greater than 10n. Notice I'm not dividing by a negative. I haven't multiplied by a negative. Yes, I added and subtracted a negative on either side, but that's not a thing. That's not an issue. The issue is the dividing or multiplying both sides by negative. So the sign does not flip, and I'm left with this. Negative 4 is greater than the number that we're looking at. So my instincts that this was a negative number that could create something like this was right. So it's not just a negative number, but it's a negative number. Any negative number less than 4 would satisfy this inequality. All right, let's take a look. I think we have more examples. Here we go, example 4. We're going to use the distributive property. Realize this is all the same stuff that you guys have been doing like since chapter 2 or something. So this is really easy for you guys. I know it is, but let's just practice anyway together. So I've got 4 times the quantity of 3t minus 5 plus 7 is greater than or equal to 8t plus 3. Just like with an equation, we're going to simplify each side first. So I'm going to rock the distributive property. Oh yeah. So I get 12t minus 4 times 5, 20, plus 7 is greater than or equal to 8t plus 3. Still haven't simplified this enough. I've got some like terms that can be joined together. So that negative 20 plus that negative 7 is going to give me a negative, what now? 13. Good job, D. So I get 8t plus 3. Now is where I'm going to decide where to put what. I want my t terms on one side. I think this side is great. And I'll put my constants, or the other numbers, on the other side. So this guy needs to move. So I'm going to subtract 8t from both sides. I'm left with 4t minus 13 is greater than or equal to 3. And finally, I got to get rid of this constant of negative 13 or minus 13, so I'm going to add 13 to both sides. I'm left with 4t is greater than or equal to 16. I'm not dividing or multiplying by a negative, so my sign stays the same. The direction of my symbol stays the same. I'm left with t is greater than or equal to 4. And just for kicks and giggles, we remember that we can write this and set builder notation, t, such that the answer to this equation or this inequality is t. All t such that t is greater than or equal to 4. And of course we can graph it, though the problem didn't ask for us to do that. It's good practice. We know that 4 is a part of the solution set, and we want t values that are greater. So we will shade to the right, which represents numbers greater than 4. All right, I think we have like one more example to go, but of course it has 2 parts. All right, example 5. Empty set and all reals. So yes, we can get situations with that weird finding where we have sometimes the empty set or all reals as a solution, and both of these will illustrate that. Each of these will illustrate one of the situations. Let's check out which one. So if we're going to solve this, again, rock the distributive property. So 9t stays the same, but now this is a negative 5 times t, a negative 5 times negative 5. I get a negative 5t plus, remember negative times negative is a positive, plus 25. So that is on the left side of my inequality. And on the right side, I'm going to distribute that 4 and get 4t minus 12. And so this looks like any old problem that we would do usually. So we're going to join like terms, do our thing. So this 9t and 5t become 4t. 9t and minus 5t become 4t plus 25. Less than or equal to 4t minus 12. Somebody is probably getting uncomfortable here, and you should be. Well, maybe not. Let's see. So 4t is on both sides. If I were to get rid of 4t on both sides, they go away. I can't so then I get 25 is less than or equal to negative 12. Is the number 25 less than or equal to negative 12? Is it? No, it's not. So this is, and you know how I get. This is a lie. When you work and you do your darndest and you make sure everything is cool and you end up with a lie or a situation that is untrue in an equation, you know that equation has no solution. And the way we talk about a no solution equation, I know that looks terrible. The way we talk about a no solution equation is we say that the empty set is the answer. There is nothing. There is a set of no numbers that's going to work to solve that equation. So the answer to this is the empty set or the null set. We'll do this next one. Again, we need to distribute and simplify each side. So I'm going to distribute by getting a 12m plus 18, which is less than or equal to 42 plus 6 times 2, 12m minus 24. Joining some like terms together, doing some cool things, I end up with 12. That looks like an n. My bad, people. 12m is less than, backtrack, Dion. Backtrack. Getting ahead of myself. 12m plus 18 is less than or equal to. Now I got to join these like terms together. 42 minus 24 is 18. So I get 12m plus 18 over here. And it's like, it's the same thing. I can subtract the 12m's from both sides. Boom, boom. When I do that, I get 18 is less than or equal to 18. Is that true? Yeah, it is true. And because it's true, and I ended up with it was like the variable portion was irrelevant, right? It doesn't matter what I put in here because it'll all cancel down to something true. The answer to this is any old number would work. All reals, right? We could write that in set builder notation as what is a variable? M, such that M is an element of the reals, my sophisticated mathematicians. So all reals, any old number will work. All real numbers, that's how we do it. So you guys have seen pretty much every type of problem that you're going to see on your assignment. So make sure you just understand what's going on here. Ask me any questions. Ask me questions about the problems as you try them. And I can't wait to see you later on. Have an excellent day. Take it easy.